Thank you, Tim.
Good Friday morning, and welcome to a brand new edition of the Backyard Naturalist, brought to you by the Urban Ecology Center. My name is Tim, and I will be your host this week as we are about to enter another torrid stretch of summer heat in a few days. Some of us have the luxury of turning on the air conditioning or moving to a cooler spot. Some of us don't. Some of us humans. The key word though is moving. We can move, and most of us can move or move with assistance, but a plant can't. And so for this week's episode, we'll be looking at how plants basically respond to changes in the weather. And a trick that they have up their sleeve is a form of migration. So we don't normally think of trees migrating individually, but as a community over generations, they absolutely migrate and sometimes spectacularly. And so I hope you can sit back and relax in some degree of comfort as we explore plant migration, which sometimes is made possible by a mighty wind. And if you haven't seen this movie, it's probably time that you did. But later, because now we are bringing you episode 45 of season 5 of The Backyard Naturalist, A Mighty Wind, the story of migrating plants, tree migration. First, we'd like to thank all the viewers that are here with us right now. We're glad you're coming along with us on this journey of learning wherever and whenever you are. And a huge thank you to all of you in the Backyard Naturalist subscriber community. Your support allows us to gather every week, rain or shine. We're excited to roll out season 6 in a few weeks, and we sincerely hope you can come along with us on that journey as well. And I do want to mention in a couple weeks, the Urban Ecology Center will be throwing a moth party celebrating those wonderful, mostly nocturnal insects, and we'll be venturing out at night to bask in their splendor. For more information, you can visit the Urban Ecology Center's website, and we'd love for you to celebrate with us. And next week, we're excited to bring you kind of a special edition of the Backyard Naturalist, special in a couple of ways. So first, we're going to be having a guest host, the amazing Emma Nickelbine, who will bring you a mini episode of the Backyard Naturalist into the Cottonwoods. And that will be followed by a special visit from Jen Hensey, who's the executive director of the Urban Ecology Center. There's a lot happening at the UEC right now, not only from a transition in leadership a while back, but there's a lot of projects happening. And so Jen will give us a very short presentation about what's happening in the organization, the current projects, what the vision is for the future, and also just to make yourself available to you for questions. So I hope you can attend that special double feature of the Backyard Naturalist. Bring your friends if you can. I will not be around for it, but I'll be able to watch it recorded later. And um, as part of the Backyard Naturalist, I'd like to keep tabs on what's going on in space and space exploration. And we've been following this harrowing journey. I don't know if you've been following it. New York Times, other news organizations have been following the harrowing journey of the Boeing Starliner mission and the 2 astronauts that were successfully transported to the International Space Station, but now have been there for a month longer than they were expecting due to several delays and malfunctions. And there's still no firm return date from Boeing. But there was just a news story this morning about the astronauts themselves and how they're dealing with this much longer stay than they're used to. And they're according to them, they're enjoying the time. They've integrated themselves into the crew that's there. So helping that crew manage a backlog of projects and experiments. So at least what they're telling us is that, they don't mind it. There's is always an expectation. They're confident in the vessel bringing them home safely, and but there still is no return date. So hopefully they are enjoying their extended stay, and hopefully they return home safely soon. And last week we talked about the at the time anticipated launch of the Ariane 6 mission by the European Space Agency, and this rocket was successfully launched just 3 days ago. So now Europe is back in the space activities. For a while, they were kind of when they had retired the one rocket, there was a big delay until when the new rocket went in. So they were relying on Elon Musk and SpaceX to get them back and forth. So now they don't have to do that anymore. This new rocket is slated for about 30 missions over the next few years, studying climate patterns here on Earth and solar radiation and other things. And then another mission that's getting closer to launch, the Polaris Dawn, which is set to become the first commercial space flight mission that includes a spacewalk. So I'm sure most of us can relate to these billionaires, Elon Musk and Jared Isaacman, who are teaming up on this. And this will be the highest altitude crewed flight since the Apollo moon missions. And this is going to go a couple hundred miles higher into orbit than the International Space Station. The International Space Station is only about 250 miles above the Earth's surface, which I guess only is relative. In some ways, 250 miles doesn't seem that far when you think of like, doing a road trip, but I guess 250 miles straight up is pretty far. So this launch is going to go about 400 and some miles above the Earth's surface. And that is just a couple weeks away. Launch date is July 31st. Also starting to keep an eye on a new Mars mission, the Escapade mission, which could send a couple of small spacecraft to orbit Mars. And this was also just in the New York Times, I think yesterday, about Elon Musk's goal of getting permanent habitation on Mars and what a Martian city would look like, and the underground portions and all of that. So this is going to launch 2 orbiters that are going to study the magnetic field of Mars. And this might be the first mission, speaking of another useless billionaire, Jeff Bezos's company, Blue Origin, might be teaming up to be the company that runs this mission. And then finally, we are approaching the peak of 2 meteor showers on the same night on July 30th. So the Southern Delta Aquarids and the Alpha Capricornids. It's not going to be ideal conditions. The moon is almost going to be half full, but still worth the effort, in my humble opinion, to go and try to find a dark sky a few hours before sunrise to look for meteors. Okay, so plant migration. Again, every week I get a lot of my information from Stuff You Should Know and that How Stuff Works conglomerate. And this episode was inspired by an episode from them that caused me to look more into this and realize just how fascinating this topic is that I wasn't really well aware of. And then also another shout out to the wonderful Birdjoy podcast, which I'm continuing to listen to, which is reaching the end of the first season. I think the final episode will come out today if it hasn't already. And then they're going to take a break and we'll have to wait and re-listen until they come out with season 2. So I encourage you to listen to the Birdjoy podcast if you can. So plants. Plants are, this is earth-breaking. They're different from us. They're different from us in many, many ways. And one of those ways is in their mobility. So there's a reason why it can be harder to go bird watching or to study birds than it is to maybe go plant watching and study plants. I'm not saying it's objectively harder, but if you find a good bird, you need to act fast. Otherwise, you might miss it and fly away. If you find a good plant, you're probably okay taking your time. Most plants, especially terrestrial plants, are firmly rooted to the ground, which gives them, a lot of stability. There's a lot of benefits to this, and a lot of problems with it. But if they're lucky enough to have their seeds grow in an ideal location, the plant could live a very long and prosperous life. But there are plants that aren't rooted, that do move in their lifetime. So phytoplankton, again, depending on how you classify plants, can move many, many miles within their lifetime because they're on ocean currents, and those ocean currents can take them very, very far, very quickly. And some plants become mobile because humans have decided to put them in pots and transport them, whether it's a seed that they planted, or whether it's a seed that they got rooted from the wild and they want to transplant. Maybe this becomes a gift to a neighbor. Maybe it becomes a gift to somebody, a different side of the world. A lot of our house plants come from the tropics of the New and Old World. So humans have become very good at helping plants migrate. And there is even a rooted terrestrial plant that technically is mobile, and it's called the walking palm, which can move in its lifetime especially if a sun gap opens nearby and it really wants to get to that sun. A lot of plants will lean towards the sun. This one is able to grow out new roots on the side that it's trying to move and lose the roots on the other side of the trunk, so that in this way the tree itself can actually move over the ground like the Ents in the Lord of the Rings, but much, much, much more slowly. There is, I should say, there is a debate over whether the tree is actually moving, but I'm going to continue to support this legend and say, yes, this is a walking palm that walks. But for the vast majority of plants, there is a huge roll of the dice once that seed hits the ground and takes root. Because once they start growing, they're not moving. So when we refer to migration in plants, it's not the herds of wildebeest moving majestically across the plains of Torquay. With plant migration, we are referring to the generational migration, because unlike us, the offspring of a tree can't grow in the exact same location as its parent, because the parent is already there. There's no house to move in. They're physically in a space, and unless physics itself changes, two plants can't grow in the same place at the same time. Maybe if you get into or alternate universes or quantum physics, but no matter what happens, the offspring of a plant or a tree by nature of physics has to grow somewhere else from their parent. And so with every generation of plant offspring, you have movement. The movement could be minimal. An acorn might turn into an oak tree mere feet from where the parent tree is. And they say the apple may not fall far from the tree. In some cases, it is beneficial if the seedling roots close to the parent, because if the parent was successful, it's likely growing up in a beneficial environment, and that would mean the offspring would grow up in a successful environment. But if it grows too close to the parent, you might start competing with that parent for resources like sunlight and water and soil and the remote control. Also, from a genetic perspective, it might benefit the seed to move far away from the parent to increase genetic variation. Or if the parent plant just grew up in crappy conditions, it would want its offspring to move off to better conditions. So it's not clear cut. Many pros and cons involved in determining the ideal distance that an offspring plant moves from its parents. But in basically every case, the offspring will root at a distance from the parent, meaning plant migration is constant. It's always happening. Plants are always migrating away from their parents, which means communities of plants are always moving and are always dynamic. Not necessarily always moving in one direction. It could be moving around in an area. And in some cases, this migration can be fantastic. A coconut palm tree can drop its offspring into the ocean, say goodbye, and that seed can literally travel across the world on ocean currents and grow on the other side of the planet from its parents. So that's some large scale migration. Any wind-borne seeds can blow across continents or from continent to continent on large air masses. Tree ferns, like the Tasmanian tree fern, they can send their spores 300 to 500 miles from the mother plant on average. And just one frond on this fern can produce 750 million spores. So these certainly can compete with the other great migrators of the world, like humpback whales. The thing I love about tree ferns whenever I see them is that in my mind, I picture just like a big old Brachiosaurus dinosaur chomping on those leaves. And they're certainly relics from an age when dinosaurs existed. So it is pretty cool to see them. So anyway, we know that plant species and communities migrate. They have to, they do. And from an evolutionary perspective, this is good because the climate of the planet has always been changing. And this generational movement allows plants to grow up under ideal conditions, under more ideal conditions to which they're adapted. Continents move, climate changes, soil conditions change, and migration allows plants to grow up under better conditions. And this has worked. This has worked for plants, since life began on Earth, and the process of plant migration is driven by climate change. And scientists who like to study things like plant migration, back in 1899, a geologist and a paleobotanist by the name of Clement Reed started to compare current and historical plant dispersal. And he noted that the historical record, the fossil record, suggests that plants have migrated at higher rates than would be expected by just looking at current migration rates. And this was later described as Reed's paradox of plant migration. throughout history, plants have migrated faster than it feels like they should. And one of the best studied climate events that paleobotanists use to look at past plant migration is the retreat of the glaciers in North America and Europe since the last ice age. So essentially, when glaciers worked their way south through Wisconsin to places like Indiana and New Jersey, um, you pretty much had no terrestrial rooted plants anywhere. It was a mile thick sheet of ice. Then, when those glaciers retreated, they left bare land to be colonized. And we can track the northward rate of plant migration in a variety of methods uh, through techniques like looking at the cores of lake bottoms. So as these plants are moving north, their wind-borne pollen might land on the surface of lakes. You see that today, sink to the bottom, and then become part of that lake sediment that gets buried and buried and buried over time. And then scientists can go back and take a core and see what plants were around at a given time and how those plants have changed. One of many ways that you can look and kind of see historically how plants have changed. Um, and then this paradox says that plants in this situation and a lot of other situations, they migrated north following the glaciers at a faster rate than one would expect based on the current real-time observations. Um, and the mechanism by which they get this is because there is assistance. Plants don't migrate by themselves. So during that 10,000 year period, oak trees traveled about 600 miles farther than one would expect. And we know how that might happen. So, but the question is why what might happen. And the why is that likely the plants were moving in a direction that was better for them, right? So if you think of evolution or if you think of moving around, if the conditions are ideal where they are now, there's no reason to move in a direction. But if conditions are worse than they are now, there's a push to go somewhere else, or if they're better somewhere else, there's that push. That's kind of how adaptation happens. And so now you have a reason for the plants to move in a certain direction, and then that's where this assistance helps out. So animals are very good at helping acorns and other seeds spread because we love to eat them, but we're not necessarily going to eat them where we find them. So might move to a safe location to eat and then dispose of the seeds. And if you can fly, of course, the distance you can take seeds is much farther. So plant migration is assisted by animals in that process. It's called zoochorai. And so that's one way that plant migration is assisted. Um, and so the other ways that we can look at plants being assisted is a process called uh, hydrochory, if it's water assisted migration, so like the coconuts, and anemochory if it's wind assisted migration. So you always like gravity kind of always usually assists plants because it gets to a place on the ground where they need to grow. But then you use these other processes, either animals or wind or water, to move them at a faster rate than they normally could go. Um, and then, if it's just gravity, you might have really round seeds that can roll down hills away from the parent plant. Um, and then you have, like I mentioned, the kind of extreme zoochory because humans can move plants intentionally or unintentionally across the world in planes and cars, on our shoes, and other ways. So there are other tools that we have at our disposal to study past migration, in addition to things like lake bottom cores and ice cores. You have satellite imagery today, but scientists about 100 years ago, 100 to 200 years ago, really started monitoring vegetation plots to see how plant communities change over time. So you can look at the current studies, and the oldest of kind of the current continual studies is about 100 years. But then you can go back farther than that and look at the journals of people in the past that have paid attention and written down what they saw. So here in Wisconsin, Increase Lapham gives us an excellent record of the vegetation of Wisconsin from the mid 1800s. I wouldn't call it a baseline because humans have been managing the land in Wisconsin for millennia before that, but it does give us a good fixed point in time to which we can measure changes, at least for the last 200 years in Wisconsin. And a Danish team recently followed the record of another naturalist, Alexander von Humboldt, comparing current conditions to the conditions that Humboldt recorded at Chimborazo volcano in Ecuador. And they discovered that pretty much every species of plant that Humboldt had recorded had migrated on average almost a mile in the past 200 years. So again, we're not talking about individual plants, we're talking about the plant community and where they're going, their boundaries. And that's significant on a number of levels. So one is the past 200 years also represents this post-industrial era, a period of time in which we humans have been really affecting the atmosphere and the climate. But another important thing to note is that this is a volcano and it functions like a mountain. And so the migration in this case didn't happen like across the surface of the earth. This migration happened in elevation. So these plants were migrating up the volcano. And scientists, we have known, humans have known for a long time that moving up a mountainside is very similar to moving north if you're in the northern hemisphere. Because if you move north here in Wisconsin, if you move north, you're going to get colder. Also, if you move up a mountain, it trends colder. And so if it gets too hot for plants or animals, the snowbirds, you would move, you know, north, the snowbirds would move south if it gets too cold. Because moving north and moving up are very similar. And of course that it's more like equatorial or polar depending on which hemisphere you're in. But it tends to get colder towards the poles and it tends to get colder up mountain peaks. So many plant and animal distributions are defined both latitudinally and through elevation. So if we want to find aspen, quaking aspen, we know we either have to head north or you go west and head up a mountain, because high elevations mimic the climate of the north. And so you get that little kind of finger of aspen that come down the Rocky Mountains. And same with birds. A lot of warblers have a distribution like this. The warblers will breed in cooler climates. So for us to find, we get warblers that migrate through Wisconsin, but we don't get a lot of warblers that breed here. Most of them breed in the north. But you can find similar conditions up in the mountains of Appalachia. So you'll often see this for a lot of the wood warblers, that their breeding range is north, but then you get this stretch of Appalachian breeding. So if you want to see warblers breeding, you can go north or you can head over to places like Virginia and the Blue Ridge Mountains. So again, it's kind of a plants, birds, everything. If they need to get cooler, they can either go north or up a mountain to seek better conditions. And the important thing to consider is that plants have always been migrating through the history of their existence on Earth. The Sahara Desert, currently almost completely barren of plants, has gone through periods known as green Sahara periods. And it happens every 23,000 years or so, based on the tilt of the Earth's axis, that the Sahara becomes green with plants. It becomes, or at least most of it, becomes hospitable to plants and to animals. And a lot of scientists think that at least if it didn't allow the human migration out of sub-Saharan Africa, it certainly assisted it. So every time the Sahara was greened, it became populated with migrating plants and animals. But the thing is, every 23,000 years, it's not the same plants and animals that are returning. Obviously, there's evolution involved, but you get the desert plants that are still there, like cacti, that kind of mix with the tropical forest species that you might find in the Congo Basin. So you get this kind of mixing and mingling of plants, which will become really important. But the idea is that plants have always migrating, and it's usually in response to these changes in climate and getting assistance from other progress. So this is probably what you knew was coming. The climate is now changing much, much more quickly, thanks to us. It's not that climate change is happening, it's always been happening, but the rate of climate change is what's troubling to us as humans. The rate of change is increasing, it's accelerating. So the car isn't just speeding along at 55 miles an hour. Someone is pushing down that gas pedal and making the car accelerate and go faster. So before the industrial age and since the last ice age, the Earth's temperature was increasing at about 1 degree Celsius every 1,400 years. Now, again, the Earth has gone through extreme changes in climate. This isn't this isn't new, but that period of warming, 1 degree Celsius every 1400 years, in the 200 years since the industrial age, the temperature of the planet has increased by another 1 degree. So 1400 years to go 1 degree, 200 years to go another degree. And the only major variable change here is what the humans have been doing on the planet. And almost half of that 1 degree has come in the last 15 years. That's scary. So in the last 15 years, the Earth's temperature increased the same amount that it took basically 700 years before humans started screwing things up. And that leads us to the really important question, can plants and other forms of life and humans keep up with this rate of climate change? The answer for plants is not likely, and I'm not meaning plants are going to go away. It's just you're likely looking at some pretty big extinctions without any help or without any change, and especially trees and bigger plants. So current estimates are that if you look at it's kind of weird to think about it, but the climate is actually moving north too, right? The conditions, the temperature, the average temperature is moving north. Um, it's not always moving north and south. Things like precipitation and other things, aspects of climate are not necessarily moving north. They might be moving inland or coastal. But if you look at kind of conditions, they're moving north at about 6 miles every year. Under ideal conditions, even with assistance, a red oak can maybe move at about 3/10 of a mile a year. So this really is the tortoise racing the hare. The hare is the climate change and that but the difference is the climate change isn't going to stop and take a nap so that the tortoise can catch up. So the oak trees would essentially have to move about 50 times faster just to keep up with the climate movements. And um, that brings up a host of questions and issues for us to consider. So if we do nothing at the current rate, we will likely see a mass extinction of plants and the animal communities that depend on them. Because one of the things we learn early in our ecology is that there's web of life. Everything's connected. So every plant is connected to other organisms, birds and fungi and other plants. Um, and then another kind of major problem is that humans have put up a ton of barriers in the way of plant migration. So we think of like fences that we put in that make it hard for caribou or other animals to migrate. But we actually also putting in barriers for plant migration to happen. Sometimes they're physical barriers like roads or huge expansions of monoculture or mining would prevent movement up and down mountainsides. So a lot of the barriers we are putting in barriers to natural plant migration. And then some of the barriers are biological. We've introduced very aggressive invasive species like kudzu that kind of act like bullies, taking all the good stuff and hoarding it from other plants. So, and it's not just the invasive plants, it's the plants and animals that are associated with those plants. So we could be bringing in more pests. So it makes it very hard because anytime a plant or an animal moves into a new area, they're looking at new connections, a new community that they have to kind of get used to, like changing schools. And then the other big force we have to consider is that each plant behaves and migrates differently. So there's a recent study out of Purdue University, my grad school alma mater. Professor Songline Fei studied 86 species of trees over 30 years and found that different plants are moving in different directions at different rates. So some plants like hardwood trees, the oaks and maples, magnolia, they're moving west towards the Midwest because they like wetter climates and the Midwest is becoming wetter for them. Is becoming wetter and that's what they like. Uh, Other plants like the softwood plants, the pines and the cypress are moving north because they're trying to get to cooler areas. So this graphic is super interesting because you can just kind of see which areas, at least of the eastern United States, are heating up the fastest. So that's the northern areas, the red. And then you can also see which areas are becoming wetter. And that's kind of like the Great Plains, Midwest area. And so we learn in basic botany that there are communities that are made up of different plant and animal species and associations. So you have maple beech, you have oak hickory, you have spruce fir, you have beech hemlock. And, we've known that this collective community of plants go well together. Uh, and because trees have such a long lifespan and generational span compared to humans, we think of these as being super stable. So an oak hickory forest, we would probably expect is just going to move to where an oak hickory forest wants to be, but the oaks are probably going to want to move in a different direction from the hickory, which is probably going to want to move in a different direction or at least at a different rate than those ground cover plants and all the other plants. So you don't get that oak hickory community moving. You get the members of that community being pushed in different directions at different rates. Maples might be pressured to move in a different direction than the beech. So you're moving away from a maple beech forest. So that's the key. Communities aren't permanent, they're unstable, but they just kind of seem permanent to us. And we talk about conserving ecosystems. We talk about conserving the oak savanna. We talk about conserving the tropical rainforest. Um, Often because we're looking at maybe a specific threatened species. And to save that species, it makes sense to save the plant community because then you're saving the other plants. So to save the Kirtland's warbler, we need to conserve the jack pine forest. And that is true. And that is still true. Um, but there is this growing push in conservation movement to start not thinking about conserving entire plant communities, but to focus more on the individual species in that community and specifically to begin to anticipate what that species will need in the future. Because one thing that was made evident by those Green Sahara periods is that plant and animal associations aren't permanent. It's like a big old country dance mixer. The Kirtland's warbler likes to hang out with the jack pine now, but down the road, that relationship might grow tired and end. The other major problem, particularly with plants, is that they just can't migrate anywhere. Maple trees are moving north in response to a hotter climate. Right now, they have room to spread out. They can keep moving north into up into Canada, but at some point, they're going to hit a brick wall. They're going to hit that boreal forest. The conditions physically and biologically are going to say, nope, this is as far as you can go. They're moving into different soil conditions. They're moving into competition from other species and temperatures. And the plants just can't wait around for those conditions to become more favorable. And so by migrating, plants are losing the connections to those important species, and they have to find new connections with new species. And if you're in a plant that's a very narrow niche, there might not be a lot you can do, and you might be the first one to go. So on mountain ranges, similarly, plants can often move up the mountain until they can't anymore because the mountain ends. So they hit a dead end and there's nowhere else to go. Um, and even before they get the point, the conditions might just be too harsh up on the upper part of the mountain. So you can't just migrate anywhere. Um, and then, oh, just one other aside, boreal forests uh, also are moving north. So the maple forests are moving north, the maple beech, the boreal forests are moving north. And the problem there is that the trees are replacing treeless areas, and the treeless areas are often snow covered, reflecting heat. And now you're putting trees into an area that was reflecting heat back into space, and now it's absorbing. So by those boreal forests moving north, you're continuing to accelerate the warming of the planet in a positive feedback loop that's not so positive. So conservationists are starting to move away from conserving what is now to conserving what likely will be, including the land management team here at the Urban Ecology Center, who's starting to look at what future plant communities will grow well in our species with plant migration spurred by climate change. And so now you also have this entire field of conservation based on predicting where plants will migrate. And it's under the umbrella of forest-assisted migration. It's controversial, as it should be, but the idea is we're trying to help these plants get a leg up on their race with the hair, with climate change. So you start to predict what an area will look like to assist the migration process. The most aggressive form of this is actually move species now ahead of the curve to areas that they might not reach on their own in time. And as we've learned, what could possibly go wrong with that, right? Moving a plant to a new area, it might become invasive. It might assist pests or other invasive species. But unfortunately, this is the reality for us, and this is all that we have to start to think of now in terms of conserving. So again, we can sit back and watch and let nature find its way. If we're okay that might result in a mass extinction, or we can put our minds and collective intelligence to trying to undo at least, or maybe ameliorate the damage we're doing. I remember, decades ago, one of my college professors talking about, we're talking about conserving the planet, and she very boldly said, the planet doesn't need conserving. The Earth is going to be here. That's not what we're worried about. We want to save life on the planet as we know. If we want to save life, that's good for us, good for our bodies, our souls. So do we want to save a planet which allows us to exist? Do we want to fight for the current suite of species and habitats that we're helping to destroy? It gets into hard and dark areas and can be very gloom and doom along with a lot of the other news, but it is our reality. And we can also do amazing things as humanity. We can do really harmful things. We can do amazing things. And so, this gets into that beer time conversation and what we can do, what we can affect, how far downstream, upstream we can go, whether it's electing leaders, understanding the effect of our actions. But this is our reality, and by the end of the century, it's fairly inevitable that the southern U.S. will feel a lot more like Central America. It's hard to predict what's going to happen on the ground in other places because there's so many things involved. I do have a great faith that humanity can work on this. I think the bigger question is, will we? And so that's plant migration. Plants need our help in many ways. I think we need to follow the wise wisdom of what Tom Cruise and Jerry Maguire. Uh, let's help the plants help humanity, help us help the plants, or is it help the plants help us? Either way, we've got a lot of work to do. I'm optimistic that we can do it. But if you take nothing else home today in this learning journey, remember this: there are trees out there that can walk. So thank you for joining today. I will stop sharing my screen.